Hello everyone, welcome to the video on GD algorithm and vectorized GD algorithm from Society of Artificial Intelligence or SOAI. I am Ritul and these notebook files are created because to deliver you the plottings in the 3D and 2D format of sigmoid neurons. So the outline is modified sigmoid neuron class. Overall setup, that is what is the data, model and task. Plotting functions in 3D and contour individual algorithms and how they perform, and finally exercise. So here for 3D plotting you can see this from mp underscore toolkits dot mpload 3D import access 3D import matplotlib dot pyplot as plt. For giving colors to the plot we are using here from matplotlib import cm and import matplotlib dot colors. For adding animations to the graph, we are using here from matplotlib import animations, rc, which I will discuss in the video. From ipython.display import html. And finally for computation, we are using here numpy, that is import numpy as np. So let's start. Here the class is sn. Class sn refers to sigmoid neuron. In this little definition, here this is the function that is underscore underscore init underscore underscore function with parameters self w underscore init comma b underscore init and algo. The two parameters self dot w and self dot b, which is equal to w underscore init and b underscore init respectively. And you can see here are three arrays which are self dot w underscore h and b underscore h e underscore h. These are tracks or error or loss at the current moment. Self dot algo is equal to algo. Now sigmoid function with parameters self, x, w and b. Here b and w is none. If w is none, w is equal to self dot w, and if b is none, b is equal to self dot b. Here it will return this statement. Next function is error function with parameters self, x, y and w and b as none. If w is none, w is equal to self dot w, and if b is none, b is equal to self dot b. Here error is equal to 0 initially. For x and y in zip x comma y, error plus is equal to 0.5 multiplied with self dot sigmoid function with parameters x, w and b minus y and the whole power 2. It is mean square error. You can see this function will return error. Now the next function is grad underscore w function with parameters self, x, y and w and b as none. If w is none, w is equal to self dot w, and b is none, b is equal to self dot b. Here y underscore pred is equal to self dot sigmoid function with parameters x, w and b, and this whole function will return y underscore pred minus y, the whole multiplied with y underscore pred multiplied with 1 minus y underscore pred multiplied with x. The next function is grad underscore b functions with parameters self, x, y and w as none and b as none. If w is none, w is equal to self dot w, and if b is none, b is equal to self dot b. Y underscore pred is equal to self dot sigmoid function with parameters x, w and b, and this whole function will return this statement, that is y underscore pred minus y whole multiplied with y underscore pred whole multiplied with 1 minus y underscore pred. The next function is fit function with parameters self, x, y, and you can see these are all the parameters here, that is epochs, eta, gamma, mini batch size, beta, beta 1, beta 2. These are the default parameters because here we are giving them values which are default. And in this function there are three arrays as self dot w underscore h, self dot b underscore h, self dot e underscore h. And when we move further, self dot x is equal to x, self dot y is equal to y. and if self.algo is equal to gd for I in range of epochs dw comma db is equal to 0 comma 0 for x comma y in zip x comma y dw plus is equal to self.grad underscore w function with parameters x comma y. Similarly, db plus is equal to self.grad underscore b function with parameters x comma y. Append the value of w and b and also calculate loss at current point self.append underscore log function. Else if, that is known as elif here, self.algo which is equal to mini batch, then for I in range of epochs dw comma db is equal to 0 comma 0 point scene is equal to 0, and this is the loop for x comma y in zip x comma y dw plus is equal to, you can see here, points underscore scene plus equal to 1. If points underscore scene modulo of mini underscore batch underscore size is, if it's 0, then self dot w minus is equal to eta multiplied with dw divided by mini underscore batch underscore size. Similarly, in the case of self dot b, and finally self dot append underscore log function. After that, dw comma db becomes 0 and 0. Here, elif self dot algo equal to momentum, then v underscore w and v underscore b become 0 and 0. For I in range of epochs dw comma db is equal to 0 comma 0 initially for x comma y in zip x comma y, and you can see here the whole thing which is performed is quite very similar to the previous one. So let's move to the next one. Here as well, v underscore w is equal to gamma multiplied with v underscore w and v underscore b is equal to gamma multiplied with v underscore b. For x comma y in zip x comma y, dw plus is equal to self dot grad underscore w function with parameters x, y, self dot w minus v underscore w. Here there is the comma self dot b minus v underscore b. Similarly for db, and when we move further, v underscore w is equal to v underscore w plus eta multiplied with dw. Similarly for v underscore b, and after that self dot w which is equal to self dot w minus v underscore w. Here the value of self dot w gets changed, and similarly for self dot b, and finally self dot append underscore log function, and this function will perform only when self dot algo if equal to add a grade. Similarly for here, if self dot algo is equal to rms probe, then these tasks are performed, and similarly for addm. Now append underscore log function with parameter self. Here self dot w underscore h dot append function with parameter self dot w, and similarly for b underscore h, and finally self dot e underscore h append function with parameters self dot error function. Here the parameters in error function are self dot x comma self dot y. X is equal to np dot sRarray function with this value. Here we are just going through the training of data, and y is equal to np dot sRarray with these values. Here we initialize the algo as its addm, and v underscore init is equal to initialized with -6, and v underscore init is initialized with 4.0. W underscore min is equal to -7, w underscore max is equal to 5, and b underscore min is equal to -7, and b underscore max is equal to 5. Here epochs is 200 initially, and gamma is 0.9, eta is 0.5, and eps is 1e minus 8. Animation underscore frames is equal to 20, and finally plot underscore 2d is equal to true, and plot 3d is equal to false, because here we are going to put the graph in 2d. Here sn is equal to, here sn small sn is point to the sn class with values w underscore init comma b underscore init comma algo. This plotting is just to check things are fine. Sn.fit function with parameters x, y, epochs, which is equal to epochs. Here epochs is equal to 200, and eta is equal to eta, which here is 0.5, and gamma is equal to gamma, here is 0.9. And after this, plt.plot function, you can see these here. And finally the plot.show function with which will plot this this graph in 2D. And finally we are going to plot in 3D object. Here plot underscore animate underscore 3D function with parameter I. Here I is equal to int function with I multiplied with epochs minus animation underscore frames. Line 1 dot set underscore data sn dot w underscore h, and after these it will return line 1, line 2 and title. So here let's talk about data for plotting. If plot underscore 3D, if it's correct, then w becomes np.line space function with parameters w underscore min comma w underscore max comma 256 from w underscore min to w underscore max. Similarly for b, and here if plot underscore 3D, if I is equal to 0, this plot is along the surface and it's a scatter plot. Line 1 comma space is equal to ax dot plot function with parameters sn dot w underscore h, with you can see there's the operator and I plus 1. And similarly for all, hair color is equal to black and marker is dot here. And similarly for line 2, if plot underscore 2D. So finally it will plot the graph which is here, you can see on this screen. Plot underscore animate underscore 2D function with parameter I is equal to int function, that is the whole thing which will return in the form of integer in the variable I. Here I multiplied with epochs divided by animation underscore frame as we studied earlier. Line.set function, line.set underscore data function with parameters sn.w underscore h. You can see the values belongs from here, and similarly for sn.p underscore h. And title.set.text function, that is epoch, which is you can see in this statement it will return line and title. If plot underscore 2D, I is equal to 0 and line comma is equal to x dot plot function. So finally if algo is ZD, then it will print in this format, in the format of algo and eta, and similarly for here. And finally the n will return. Let's move to the vectorized GD algorithm. Similarly, for the vectorized GD algorithm, this is the setup, and as usual we are importing some files as numpy, matplotlib.pyplot and many more. So here this is statement, that is my underscore cap is equal to matplotlib dot colors dot linear segmented color map dot from underscore list. This here you can see red, yellow and green, these are the colors which the plotted graph show, which will the plotted graph show. Here np.random.seed 0. Here we are going to generate a data comma labels is equal to make underscore blobs in underscore samples is equal to 1000 comma center is equal to 4 and n underscore features is equal to 4 comma random underscore state is equal to 0. And print data dot save comma labels dot save. You can see this data dot save which is equal to 1000 comma 2 here, and labels dot save is 1000 here. Plt dot scatter data, you can see, and after that plt dot show function, it will plot the graph here. So labels underscore orange is equal to labels, and labels is equal to np dot mode function with labels underscore orange comma 2. And finally plt dot scatter data and other variables you can see here. And finally when we are going to plot the graph as plt.show function, this will plot the graph here. And multi-class classification, xtrain comma x underscore val comma y underscore train comma y underscore val is equal to train underscore test underscore split function. As here the parameters are data comma labels underscore orange comma stratify is equal to labels here, and stratify is equal to labels underscore orange here comma random underscore state is equal to 0. And print function with x underscore train dot save which will return 750 comma 2, and it will print 750 comma 2. And x underscore val dot save which will print 250 comma 2. and labels underscore orange dot say it will print 1000 comma. Here enc is equal to one hot encoder function. Here y underscore oh underscore train is equal to enc dot fit underscore transform function with np dot expand underscore dims function y underscore train comma 1 dot to array. Similarly for this, and finally when we are going to print, it will show the statement and w1 is equal to np dot random dot rand n 2 comma 2. Similarly w2 is equal to np dot random dot rand n function to 2 comma 4. When we are going to print w1, it will print the random variables here, you can see this, and when we are going to print w2, it will also going to print random variables. Now ff class here this is the ff network class with constructor function underscore underscore init underscore underscore function self comma w1 comma w2. Here model is equal to ff network function with parameters w comma w2. It will call the class here, and these things will perform, which is quite similar to the previous one, that is GD algorithm .ipynb file. And after this model.fit function x underscore train comma y underscore oh underscore train comma epochs is equal to 100 comma eta is equal to 1 comma algo is equal to gd comma display underscore loss is equal to true. Print underscore accuracy function, as this function will call, it will form the graph. Here you can see plt.show function, it will plot the graph, and these are the. Similarly for next one, here the accuracy chart is given as follows. Similarly for this one, actually we are just going to change the values, and the plotted graph comes out very different. Here training accuracy is 0.693, validation accuracy is 0.876, and CPU times user 976 ms, you can see this here. And when we're talking about this, accuracy is 0.8867. Here the accuracy is greater, and also validation accuracy is more here. Similarly for this one, and finally this one. Now good configurations with each algo. Model is equal to ff network function with parameters w1 comma w2 model.fit function, that is x underscore train comma y underscore oh underscore train comma epochs is equal to 10,000, eta is equal to 0.5, and algo is gd comma display underscore loss is equal to true. Print underscore accuracy function, you can see the plot graph here. Here accuracy is 0.9293, validation accuracy is 0.936, and so on. And you can draw your own graph by just changing the values. So here the exercise is duplicate this exercise for a smaller network with 3 neurons binary classification. In this case you can practice writing the vectorized form of the gradient descent. After training for a few epochs, freeze updates to all variables except to say w underscore 1 and w underscore 2 in our diagram. Now we have a situation similar to the previous setting where there are two variables and we plot 2D and 3D plots. Plot the error surface and animate to visualize each algorithm. Try one with different parameters, say w underscore 3 and b underscore 2, and observe how the algorithm works. The SOAI thanks you.